2, 8. I'm going to erase all this. Two 8 is the simplistic stuff. I've been debating whether I should even teach it. I should just make people watch videos online because it's so easy. Seriously, this is simple stuff. Distance, midpoint, and circles. Distance, midpoint, and circles. So it's just some formulas that they throw at you at the very end of this chapter. They fit pretty much anywhere in the textbook, so they just kind of threw it here. Though I don't understand why they ever put it in the function place, because circles are definitely not functions. They fail the vertical line test completely. But this is where they put it. All right, so let's talk about it. Here's 2 points. Oh, my black marker's dying now. Hook shot. Almost. I missed that one too. I'm doing good tonight. Let's see. Let's call this P1, X1, Y1, and some other point over here, P2, X2, Y2. Point 1 and point 2. Oh, let's go back to the first day of class. Remember the first day of class? Way back when? It wasn't that long ago. It was like, what, 5 weeks ago? If you have a number line and you have 2 values in a number line, A and B, how do you find the distance between them? Remember I told you we'd come back to this? I bet you remember me saying we'll come back to this, but you don't remember what the heck it is. If this was 3 and this is 5, how do I find the distance between them? How far is 3 from 5? 2 units. What did you do to the 3 and the 5? You subtracted them. But if you did it out of order, the sign would have been wrong, so it's the absolute value of A minus B. The distance between A and B is the absolute value of A minus B, as long as you're on a number line. Do you remember that now? Because I was teaching absolute values at the time. But that only works if the values are on a number line. The line segment between P1 and P2 is not on a number line. It's a diagonal across a rectangular coordinate system. If we were just moving horizontally, we could use this formula down here. And if we were moving vertically, we could use this formula down here. So how do I force this to move horizontally and vertically? That's easy. Start here, draw a horizontal line. Start here, draw a vertical line. There's our horizontal and vertical motion. Okay. How far is it along the base of this triangle? What's the distance on that side? What's A? What's B? If you're over here underneath this point, what's A? X1. If you're over underneath this point, way over here, what's B? X2. So what's the distance along that line? Does that my formula say plus?
Oh,
So it would be X1 minus X2. Don't forget the absolute values. All right. Then, what's the distance along this side? Sure, why not? Y2 minus Y1, but don't forget absolute value. Now, whether it's X1 minus X2 or X2 minus X1 is irrelevant, right? 2 minus 5 is the same thing as 5 minus 2 as long as it's inside of absolute values. We'll eventually switch it around so they match up order-wise, but right now it doesn't matter. What kind of triangle is that? It's a right triangle. It's got a right angle here. Vertical and horizontal line come together. I want to find the distance of the black line here. So this is D. How do I find the distance of that black line? Pythagorean theorem. So we set up the Pythagorean theorem and we say c squared must equal a squared plus b squared. Remember, I always write mine backwards because c is more important than a and b. Hypotenuse. So in this case, what's c represented by? D. Equals, oh, d squared, equals, what's a represented by? Minus x2 an absolute value, right? I'm going to flip it around anyways. So I'm going to write it as the absolute value of x2 minus x1 all squared plus, what's b? All squared. Yay! Okay. What do absolute values do to numbers? Makes them positive. If you square a number, what happens? It becomes positive, whether it was negative to begin with or whether it's positive. So these two operations are forcing the thing to be positive twice. I really only need to force it to be positive once. Which one can I get rid of without changing the value? The absolute value, because square is going to make the number bigger generally. So I can drop the absolute values. So I get d squared is equal to x2 minus x1 all squared plus y2 minus y1 all squared. Almost done. We're trying to find the distance formula, the distance between these 2 points. So I want to get d by itself, so you just have d by itself. So how do I get d by itself? Square root both sides. Now, if you square root both sides of an equation, what are you supposed to tack on? Plus or minus. Am I going to do that in this case? Why? Because of the way you said it. I guess I left you a clue there. Distances. Can I travel negative 500 feet? No, unless you're in physics. And we are definitely not in physics. This is a physical distance, so it has to be positive. All right, that is one ugly formula. People get confused with it. Why? Minuses, the pluses, and a minus. Some people will put a plus here, a minus here, and a plus there. That would be me when I was learning this. So I always got confused with it. So there's another way of writing it. You have seen x2 minus x1 before. What did we call it? Change in x. So another form of the formula is this. Change in x squared plus change in y squared is another form that I like of the distance formula, because it kind of goes back into what does it mean to be change in x. Take your x values and you subtract them. So you don't have to memorize too much. So either formula works perfectly fine. And they're easy to work with. For example, find distance between -4, 7, and 5, -3. Just make it up numbers. If you're comfortable with this formula, just plug the numbers into it. Be really careful of negatives. Especially next to that minus. If you're using the second formula, I highly suggest you find change in x first and change in y first. And then just plug those values into the formula. Which way do you want to do it? Change in x. So if I do the change in x, change in y part, what's change of x equal to? Don't think slope here. This is totally slightly different than slope. So what's change in x? It would be -4 minus 5, better known as -9. Change in y? Nope. Yep. I lied. 7 minus a -3, better known as 10. So the distance formula is going to kick out this way. It's going to be something squared plus something squared. What's the first something? -9. And if you drop the negative, it'll still give you the right answer, because you're eventually going to square it and it's going to eventually become positive. A lot of people make a mistake by typing that in their calculator, but they type it in this way and it'll give them the wrong answer. So if you want to drop the negative in the distance formula, you're safe. This is -81. The answer is supposed to be +81. If you want the positive answer, you've got to put it in parentheses in your calculator. All right, this other number is what, 10? So this becomes the square root of 181, which I don't think breaks down very well. 181, 2 doesn't go into it, 3 doesn't go into it, 4 doesn't go into it, 5 doesn't go into it, 7 doesn't go into it, I don't think. Well, you all have calculators, does 7 go into it? Do you know how far you have to test to find out what goes into it? Literally take the square root of 181, find the answer. You don't have to go any higher than that. What's the square root of 181? It's like 13 point something. Yeah, so the highest number you can have to try is 13. If none of them go into it, it's prime. I don't think anything goes into it. No? We tried. So the distance is equal to the square root of 181, which is really close to 16 point something, something, something. Whatever. Approximately. All right, so that's the distance formula. Not that bad. Most people do things good with that. Except break down the radical. Midpoint. Trickier. Properties we need to know. Huh. Ready? We're going to do geometry. It's been a while, right? Geometry? Remember geometry class?
No.
Proofs, reasons, statements and reasons, and all that fun stuff, and theorems, and definitions, and all that. Yeah, that junk. If you have a rectangle, what are the properties of a rectangle? Has 4 right angles. What else? Great. And what's true about the 4 sides?
The ones opposite are equal.
Thank you. Opposite sides are congruent on a rectangle. Or parallelogram. Same thing happens with parallelograms. Alright, if you have 2 parallel lines cut by a transversal, you remember these things, right? 2 parallel lines cut by a transversal, these 2 angles are congruent. Why? They are called corresponding angles. Do you remember these? No?
Yeah, don't ask me how long ago it was.
If you have 2 triangles, so that, 2 right triangles, by the way, it's kind of important for 2 right triangles in this case, where this leg is congruent to this leg and this leg is congruent to this leg, then the 2 triangles are congruent. Remember this little symbol? Congruent. Yeah? You need to geometry better in high school. Now, when 2 triangles are congruent to each other, everything else about them are congruent. Their hypotenuses are now congruent. These 2 angles are now congruent to those 2 angles. Everything becomes congruent. It's called CPCTC. Bet you don't remember what that is. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. We're going to use these ideas to prove 1/2 of the midpoint formula. We're not going to do the whole thing because the second half is horrible. First half is bad enough as it is. Big picture. 2 points. P1, and someplace over here, P2. Now remember, P1 has coordinates x1, y1, and P2 has coordinates x2, y2, just like the distance formula. Oh, before I do this, there was one other thing. If this is A and this is B, how do I find the coordinate of their midpoint? If A is 7 and B is 13, What's halfway between 7 and 13? How do you find out? If you made a 90 on your first test and a 75 on your second test, how do you find your average? How do you find it? Add them together and divide by 2. So to find m is literally equal to a plus b divided by 2. It's literally their average.
You don't remember any of this stuff?
So what I propose is, I think this has a midpoint. I don't know where it is, so I want to find it. I'm going to draw my picture really badly from now out. I think. I might have drawn it too perfectly. I drew that too perfectly. So I'm going to have to draw the rest of my picture really, really badly, but prove that something is happening. So the first thing I'm going to put in is a horizontal line all the way across, and a vertical line all the way down. So we get that same right triangle that we did for the distance formula. But then I'm going to cut the bottom leg of this right triangle in half, and I'm going to do it badly. This is how you prove geometry. You draw it badly and force it to look nice. So if I'm going to do it badly, I'm going to offset it over here. There's my midpoint along the x-axis. Does it look halfway in my picture? No. But I say it's there. Sounds good? You'll have to trust me. All right, then the midpoint on the y-axis is here. Another drawn really badly picture. But don't let that fool you. I'm just making sure it's drawn badly. All right, so I'm going to get 2 triangles out of this. This one and this one. Now notice where they're intersecting here. Nowhere near that M. So my point of this proof is to prove that the green dot is the same as the black dot. That's the essence of geometric proofs. You have to show that if they are separate, you prove that they're exactly the same. This is like f of a equals f of b, that type of thing. All right, so how do I prove it? Well, number 1, if this is the midpoint along the x-axis, right, this would be x1 plus x2 divided by 2. That's literal midpoint along the x-axis. Remember, the first point is x1, y1. The second point is x2, y2. So it would be the sum of the x coordinates divided by 2. And y, similarly, however you say that, is going to be y2 plus y1, or y1 plus y2 all over 2, the average of the y's. Okay, if m sub x is the midpoint along the x-axis, what's true about these 2 line segments? They're equal. So this line segment is congruent to this line segment. Remember, these little dashes mean congruent. All right, if my is the midpoint between here and here, then what must be true about those 2 line segments? Do they look equal? Mm-hmm. But geometry says they are, so we say they're equal. This one is equal to that one. There's a reason I drew it ugly, so you don't assume things by looking at the picture. You prove things by proof. All right, now here comes the rectangle part. This is the rectangle here, right? If this side has 1 mark in it, the top side also has 1 mark in it. If this side has 2 marks in it, the opposite side has 2 marks in it. Okay. Now I just want to look at this triangle and this triangle. So far, so good. What's true about those 2 triangles? Well, 1 dash on the bottom, 2 dashes on the side, 1 dash on the bottom, 2 dashes on the side. What's true about these 2 triangles? They're congruent because of leg of a right triangle. All right. If they're congruent, then everything else must be congruent, right? So that means their hypotenuses are also congruent. They're equal. That forces the green dot to be on top of the black dot. And that's the whole proof. Therefore, this side is equal to this side, and this point must be that one. So to find the coordinate of m The x-coordinate is x1 plus x2 over 2, and the y-coordinate is y1 plus y2 over 2. So m has a coordinate of x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. That would be the coordinate of the midpoint, or loosely phrased, the midpoint formula, even though it's really not a formula. The formulas usually have equals in it that don't have equals.
Okay.
That don't have equals. So the midpoint of any two coordinates is the average of the x's, average of the y's. No need to memorize the formula. It is the average of the x's, average of the y's. Isn't that a neat proof of? In a weird way? Don't you want to take geometry again?
No.
Ah, that was my favorite topic of all time. Geometry teaches you to not assume anything. Just because someone says it's true doesn't mean it's true. But how many people read those emails that say, oh, I'm over here in Brazil and my husband died and he left me all this money and I need you. Have you ever read those? People actually believe those things. Send us $5,000 and we'll send you $1 million. Sure. They didn't take geometry. So, for example, find midpoint between -3, 8, and 4, 7. So how do you find the midpoint? You find the average of the x's and the average of the y's. What's the average of the x's? It's going to be -3 plus 4 divided by 2. And then the average of the y's is going to be 8 plus 7 divided by 2. This is the reason people screw up the distance formula. Where the distance formula is the change in x, the average formula is the sum of x. And then it gets confused which one is a plus and which one is a minus. That's why I like the change in formula for the distance and average for midpoint. If you say those two things, you won't screw it up. All right, so this is what, -1/2? No, +1/2. And see, I can't add. That's why you have a calculator next to you. So the midpoint between these 2 points would be 1/2, 15 halves. 0.5 and what's that? 7.5. That's it. That's midpoints. Simple, right?
You said that was really hard.
The proof is hard.
Okay.
The formulas are nothing.
Okay.
The proof of why it exists the way it does, that's a little tricky for most people. All right, so that leaves one last topic, and we're going to spend most of the time on it. Circles. And we got plenty of, well, no, we don't have plenty of time, so I'm going to have to run through this rather quickly and force you to watch videos. Short ones, just the 5-minute ones, not the long ones. This you can see in a 5-minute video. So really quickly, what's the definition of a circle? Sad. No one knows what a circle is. You can image it in your head, but you have no idea how to define it. So what makes a circle a circle? Yeah. But how? Let's put it this way. If you were going to draw a perfect circle, what would you do? No shot glasses involved.
Put a dot in the middle and then use a protractor, compass.
Compass. What's a compass do? It gives you a pointy end that you stick in the paper and holds it still, so it's a fixed point. Then you expand it out to a certain distance, and you keep that distance exactly the same, and then you draw it around, right? So a circle, by definition, is all points in a plane. Yeah, I better put that in there.
You're good.
If I don't put in a plane, then we have a sphere.
Oh.
Basketball, basically. All points in a plane equidistant from a given point. Now this given point is called the center of a circle. It is not part of a circle, it is just it's not a point on the circle, it is just a point within a circle that defines the rest of the circle, I guess. But it's not a point that you use as a circle. Circle is this. The center is here, but technically it's not part of the circle, because the circle is just this on the outside. All right, so all the points in a plane equidistance from a given point. Fine. Here's my given point. Let's call it HK. Oh, who painted the Sistine Chapel? Michelangelo. How did he get the job? See, you had to interview for jobs and show, your professionalism on your drawings, and most artists would give samples of things they already drew. So this guy came to Michelangelo and said, I need a sample of your art if you want to do the Sistine Chapel. He didn't want to give up any of his paintings, so he took out a piece of canvas, drew a perfect circle, and gave it to him.
What?
Drew a perfect circle.
Wow.
Freehand.
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 Back in those days.
That's how he got to paint the Sistine Chapel. Isn't that cool? I love stories. I wonder if it's true, though.
Ha ha ha.
You never know. I mean, you hear these things, and it could have been made up over the years.
Yeah.
Like urban legends and things. All right, so here's our fixed point. We want to go a certain distance away from that fixed point. Oh, by the way, what's that certain distance called? In a circle. Radius. So this would be the radius. And then we want to generate all the points that have that same radius all the way around. So all those little dashes are all the possible points that are equidistant from the center, HK. Okay. How many of those points exist? 1, 2, 3, 4. How high can I count? If you draw a circle, how many points are on it? Infinite. How do you represent an infinite number of points without really representing any of them? Use variables.
Oh.
So, you take this point here, you say this point is on the circle, and we're going to represent all the points on the circle with x and a y. Where x is any point on the circle, and y is also any part of the coordinate on the circle. In other words, x, y is all the points on the circle. Okay. So, by definition, all these x, y's must be the same distance, radius-wise, away from hk. That sounds like we need to use the distance formula. So we go distance is equal to the square root, change in x squared, plus change in y squared. Alright. But we've called the distance between hk and xy the radius. So I'm just going to call this r. R. There. And r is going to equal the square root of, what is the change in x between those 2 points? X and h, right? So this would be x minus h, all squared, plus the change in y all squared. What's the change in y? Y minus k, all squared. All right. I don't like that formula already because it has a square root in it. So I'm going to get rid of the square root. I'm going to switch sides. And I'm going to declare that this is the equation of a circle. This is a circle whose radius is r and center is h comma k. Wow, that's easy, isn't it? Let's laugh sometimes. So, what will I ask you about a circle? is the center and radius of this circle? So you go back to the formula, but you got to look at it right. X minus h, h is the center. Right? So when it's x minus h, you have to take the h and change it back to its opposite. This is like translations. If it's inside parentheses, it goes opposite direction that you think. That says minus 3, but you know it goes minus 3. You would think it would go 3 to the left, but that really goes 3 to the right. So when we talk about the center, this is actually going 3, right 3. Where's this one going? Is it going up someplace? Up which way? There has to be a number next to it. There's no number next to it. So where's it going? Nowhere. It's going absolutely nowhere. So this one is 0. It's not going up, it's not going down, so it must be 0. Another way of writing y squared would be y minus 0 all squared. And therefore the center is
Right 3.
the center got moved 3 units to the right, no up and down. So it's at 3, 0.
Question, like, the reason why it's going the right way because clockwise is negative and counterclockwise.
That has nothing to do with that. It has to do with the formula. It says x minus h, and h is the center. So if this is minus h, you have to change its sign to get it correct. And since there's nothing next to the y, then the other part of it is just 0. Just 0. What's the radius? Well, I highly suggest you do this. R squared must equal 16 by the formula. The number is equal to r squared. So r is equal to 4 square root of 16. And there's your answer. Center of 3, 0, radius of 4. Do they get harder? Yeah. For instance, what if we had x squared plus 8x plus y squared minus 10y minus 3 is equal to 0. This thing doesn't even look like the equation of a circle. But can I force it to look like the equation of a circle? Of course, otherwise why would I ask, right? So how would you do it? How would you create, look at this correctly, this is a perfect square. X minus h all squared, perfect square. How do you create perfect squares? There's a method. We learned it last chapter.
Oh, yeah, move the 3 to the other side.
That's part of it.
And the x, half of 8x.
Which is the 8.
You take
Oh, yeah, just say
What's it called though? What's that method called?
perfect square.
It's not crap. You always say things are crap.
Well, I can't-
That's your mathematical language. This crap theorem. Jeez. It's called complete the square.
Yeah.
Completing the square. So, move the 3 to the other side. To complete the square, we have to do it twice. On the x's and on the y's. So you have to set it up nicely. It's got to go x squared plus 8x, leave a space, plus y squared minus 10y, leave a space, equals 3. Why do we need the spaces? Well, we're going to put something in there. So completing the square, keep the x's together, keep the y's together, give spaces for what we're going to do. Half of 8, positive 4, square it, positive 16. I have just added 16 to the left-hand side of an equation. Add it to the other side, plus 16. Don't leave it off just on one side. Then you come to negative 10, and you take half of negative 10. Negative 5. Square it. Positive 25. You have just added 25 to the left-hand side. Add it to the other side. All right? as a perfect square, what does the x terms turn into? X plus 4 all squared. So this is x plus 4 all squared. Plus, the y's will turn into, no, not x, y minus 5. And the other side is 41, 44. You're asking me to add, and I'm not good at it. You all picked up a calculator, that's even sadder. 44, right? Okay, 44. All right, so what's the center? It's in the right form now. Center. Post no cigar. Remember, opposite direction. It's inside parentheses. So it's not 4 negative 5, it's negative 4 and positive 5. So the center is at negative 4, 5. Highly suggest you do this. R squared is equal to 44. So therefore R is equal to, better known as, 2 square roots of 11. So the center of the circle is negative 4, 5. The radius is 2 square roots of 11, which is about 6 or 7, give or take a little bit. How much time? Yeah, that's it. One little hint. On your homework, you're going to be given 2 points on a diameter, and I want you to find the equation of a circle. So if this is a diameter of the circle is going like this. How do I find the equation of the circle? What do I need? I need a radius, and I need those 2 pieces, center. I need the center. So how do I find the center of a diameter? Midpoint. So you use the midpoint formula and you come up with the center. How do I find the radius? Find the distance of the diameter and cut it in. That's all there is to it. So you're using the midpoint formula and the distance formula to find the equation of a circle.